Chapter 6 Bending Part A Centroid Concept Example 3. Just assume we have a assembly consists of two parts, which is a cylinder and a box. And we want to know what is the dimension h. We want to know what h is in such that we have the centroid of C of assembly lies at the base of the cylinder. And this is the base of cylinder. Let me, this is the base of cylinder. Mhm. So to start our problem, we want to have the centroid of bowl shape at the to be located at the centroid at the base of the cylinder. So if we were observing them separately, the centroid for our cube was something like here. Mhm. At the centroid, at its own centroid. And again, the centroid for the cylinder was halfway through, so this is the 2.5, and this is let's have it here to be at the same distance. So if this is h, centroid would lies at h over 2. This was our centroid for our cube, and the other one is the centroid for the cylinder. But if we want to have for the assembly to be located at centroid, it means the centroid for the first shape should move to H, and the centroid for the cylinder should comes back to H. So let's see how that works. The other dimensions are provided. So this is 6 inch, height is 6 inch, length of cylinder is 5 inch, diameter of cylinder is 2 inches. Mhm. Let's see how we can approach our problem solution. So if you remember from centroid for discrete part, it says summation of xi vi. So this is our x for centroid, and we want to x component of centroid lies at the base of the cylinder. So xi vi, x of centroid for each uh, piece. For example, if we just 1 and 2, x1 times v1 plus x2 times v2 is it's equal to x bar for the whole assembly. In that sense, we can say the centroid for the cube itself is h over 2 as we told, and times the volume h times 36 6 times 6 times h, and the centroid for that is h over 2 plus the other half is the pi times 2 squared, pi times 2 squared, the area for cross section of our cylinder times the length of cylinder, which is 5 inches. Mhm. And then centroid for the cylinder from our base. Yes, we just consider this is our base for x axis. So this is h over 2. The other one is h plus 2.5. So this is the centroid of cylinder alone, and that's 2.5 halfway through plus h over 2. So that's halfway through of cylinder plus the whole h. So this is h from our center plus halfway through to the centroid of the cylinder itself. So that's just h plus 2.5 times the volume of cylinder. And if that should be equal to, we want to have the centroid of assembly at the base of the cylinder. So that's the x of h. H in bracket the whole volume. So that's h times 36 plus pi to a square times 5. If these two are equal to each other, we need to solve a 2-degree equation just for second degree equation for h, and based on that it just gives us, if you simplify this equation, it just gives you 50 times pi is equal to a half of 36 h squared. And if you solve this for h, it just gives you h is equal to almost 2.95 inches. So that's what you do need for H. You have the centroid at the base of the cylinder. Mhm.